Have you ever wondered how a tiny app, maybe built on a single laptop, grows up to serve millions of people all over the world? Well, today we're going to find out. We are going on a journey building a service from the absolute ground up. We'll start with just one user, and we will tackle every single problem that gets in our way until we reach a massive global scale. So this is the big question, right? Every huge company you can think of started somewhere small, probably with one server humming away in a closet. So how do they make that leap? It's really a story about solving one engineering puzzle after another, where each solution unlocks the next stage of growth. Let's dive in. All right, every epic journey has to start somewhere. And for a brand new digital service, that start is almost always the same: one single lonely server. So in this first setup, everything, and I mean everything, the web application, the database that stores all the data, it's all running on one machine. And you know what? It's beautifully simple. It totally gets the job done for your first user, your first 10 users, maybe even your first 100. But that simplicity, that's also its biggest weakness. It's fragile. With everything in one place, you've got a single point of failure. If that server goes down, the whole show is over. Okay, so let's say your app is a hit. This is amazing news, right? But it immediately shines a huge spotlight on the weakness of our single server, because more users means more traffic, and that one little server, well, it's starting to get overwhelmed. You're seeing the classic signs. The website is slowing down, maybe it's even crashing during peak hours. Now, this is what they call a good problem to have, but it's definitely still a problem you have to solve. And you can't just keep buying a bigger and bigger server forever. So what's the move? You bring in a load balancer. Honestly, the best way to think about this thing is as a traffic cop for your website. Instead of all the requests getting jammed up trying to hit that one server, the load balancer stands in front and intelligently directs the traffic, spreading it out evenly across a whole fleet of servers. So here's how it works in practice. A user's request goes to the load balancer's public address first. Then, the load balancer picks one of the healthy web servers it manages on a private network and forwards the request there. This is a total game changer for two reasons. First, availability. If one of your web servers fails, no big deal. The load balancer just stops sending traffic there. And second, this unlocks what we call horizontal scaling. Need to handle more traffic? Simple. Just add another server to the pool. So we've solved our web traffic problem. But in system design, it's like a game of whack-a-mole. You fix one bottleneck, and another one immediately pops up. Now, all of our shiny new web servers can handle the traffic, but they are all hammering our one database, which is now struggling to keep up with all the requests to read and write data. The solution here is something called database replication. The idea is to create copies of our database, but give them different jobs. We set up one database as the primary. Its only job is to handle writes, so any new data, any updates. Then we create multiple replica databases. These are exact copies of the primary, and their only job is to handle read requests. Now, this setup is incredibly powerful because for most applications, you have way more reads than writes. Just think about how you use social media. You scroll and read dozens of posts for everyone you write yourself. So by offloading all of those read requests to a whole bunch of replica databases, we can serve a massive audience without slowing down that crucial primary database that's handling the new data. And this brings us to a really core concept in this whole field: vertical versus horizontal scaling. Vertical scaling, or scaling up, is like buying a bigger, more powerful server, more CPU, more RAM. It's simple, but eventually you just can't buy a bigger machine. You hit a physical limit. Horizontal scaling, or scaling out, is what we've been doing. We just add more servers to the pool. It's way more flexible, it's basically infinitely scalable, and it makes your whole system much more resilient. Okay, so check this out. Our system is now stable. It's scalable. It can handle a ton of traffic. But as our app gets popular all around the world, a new enemy appears: latency. The simple physical distance between our servers and our users is starting to make the app feel slow for people far away. And why does speed matter so much? Well, let me put it this way. About a decade ago, Amazon figured out that just 100 milliseconds of delay, literally the blink of an eye, cost them 1% in sales. 1%. In the digital world, speed isn't just a nice feature, it's money. So, how do we get faster? One of the most powerful weapons in our arsenal is a cache. Think of it like a super fast, temporary memory that sits right in front of your database. It stores the data that gets requested all the time. Getting data from the cache is orders of magnitude faster than going all the way to the database. It's the difference between finding something on your desk versus having to run to the library to look it up. Now, to solve that problem of physical distance, we use something called a Content Delivery Network, or CDN. This is basically a network of servers spread all across the globe that store copies of our static stuff, things like images, videos, all the visual assets. So now, when a user in, say, Germany requests an image, they don't have to wait for it to travel all the way from a server in California. They get it from a local CDN server right there in Europe, and the site feels like it loads instantly. We're fast now, and we're stable. But to really serve millions of users 24/7 without a hitch, we need to start thinking about true resilience and decoupling the different parts of our system so they can operate and scale all on their own. So this is the big one. The ultimate in resilience is a multi-data center setup. Instead of having all of our eggs in one basket, we basically clone our entire system in different parts of the world. We use smart routing to automatically send users to the data center closest to them, which is great for speed. But the real superpower is this. If an entire data center goes offline, maybe a power outage, a natural disaster, whatever, all the traffic just gets seamlessly rerouted to a healthy one. The user has no idea anything ever went wrong. The next key tool for this level of scale is the message queue. You can think of this like a post office for our system's different services. It allows one part of our system to send a message, or a job that needs to be done, to the queue, without having to wait for another part of the system to be ready to handle it. It's a buffer. It lets them communicate without being directly connected, or what we call asynchronously. Here's a perfect example of why that's so awesome. Let's say a user uploads a new profile picture. That photo needs to be resized, maybe have a filter applied. That's a slow, intensive task. Instead of making the users sit there and wait for it to finish, the web server instantly drops up process this photo job into the message queue and tells the user, yep, got it, your upload was successful. Then, later on, a totally separate group of worker servers can pick that job up from the queue and do the heavy lifting. It makes the app feel lightning fast from the user's perspective. So we've gone on this huge journey. We've talked about load balancers, databases, CDNs, all this cool tech. But honestly, the most important thing to take away from all of this isn't any one piece of technology. It's the mindset. It's about how you think when you put all these pieces together. Just look back at what we've built. We started with one server. When traffic hit, we added load balancing. When the database choked, we used replication. When we needed to be faster for a global audience, we brought in caches and CDNs. And for that ultimate bulletproof resilience, we set up multiple data centers and message queues. Every single tool was a direct answer to a new problem we faced as we grew. And this quote right here, this really gets to the heart of it all. There is no such thing as a perfect or correct answer in system design. Every single choice you make, every one, is a trade-off. And it almost always boils down to these fundamental conflicts. For example, do you prioritize consistency, meaning every single user always sees the absolute latest, most up-to-date data? Or do you prioritize availability, meaning the system is always online and working, even if some of the data is a tiny bit stale? Do you build the absolute fastest system money can buy, or do you have to balance that against the very real-world constraint of cost? There's no right answer. There's only the right answer for your specific situation. This journey from one user to millions isn't just a technical problem to be solved once. It's a continuous series of decisions, of balancing acts and judgments. And as technology changes and what users want changes, the right trade-offs will change too. So the only question left is, the next time you're building something, what will you choose to prioritize? Thanks for joining me on this journey.